Hi everyone. We're going to continue our discussion of using mean and median to analyze data. And what we're going to do today is we're going to look at two different graphs and we're going to compare two different populations. When we compare populations or when we compare graphs, we look for three things. We look for center, so we're going to look at mean or median. We look at the shape of the graph, and then we look at how the data is spread out. If it's mean, we're going to look at that mean absolute deviation. If it's median, we're going to look at that interquartile range. So, when we begin to compare populations, we're going to look at mean, which is the average, or we're going to look at median, which is the middle. When we talk about the shape of the graph is how the graph looks. Does it look like the data is kind of evenly dispersed, or is there data on one end and not so much on the other? And the way we're going to describe that is we're going to say that our shape is either symmetric, meaning that the data is even on both sides of either the mean or the median, or my data is skewed, meaning the data is at one end, so the graph looks like it's not even. If I were going to fold along the median or the mean, it wouldn't match up evenly. Now, when we talk about spread, if we're dealing with mean, we always have to do the MAD, and that would be your mean absolute deviation. Those two go together. And then if we are looking at median, then we're going to look at the IQR, which is the interquartile range. And the interquartile range is only used with median. All right, so let's see how this looks. Let's look at the first problem. So now, I have two companies, and they have graphed their daily participants. I have Treetop Tours and I have Zip Adventures. Now, as I look at this, first of all, this is a box and whisker. So I immediately know that the measure I'm going to have to look at is median. So I'm going to need to find the median of Treetop, and then I'm going to need to find the median of Zip. Now, I have to use median because remember, a box and a whisker divides a graph by the median. So when I go to Treetop, right there is my median. So for Treetop, my median is 70, and for Zip, my median is 50. So if I look just at the median, it would seem like Treetop has more customers than Zip. Now, the next thing I'm going to look at is I'm going to look at the shape of the graph. And this is where I need to kind of find the median and then look and see what the left and the right look like. Well, if I look at Treetop, the data is a little bit kind of not equal. If I were to fold right here, this wouldn't match evenly. So we're going to say that the data for Treetop is skewed. Now look at the difference. Look at Zip. If I were to fold right along the median, why, that would match perfectly. And actually, if you even look at the way that it's dispersed, there's 10, 10, 10, 10. I don't have that nice evenness at Treetop. Plus, I also have this outlier right here at Treetop. So Zip is more symmetric. Now, when I use median, I have to use the interquartile range. So on Treetop, the upper quartile is 80. I'm going to subtract 50, so my spread or my data interquartile range is 30. Okay, and that's IQR. Now for Zip, my interquartile range is 60 minus 40, which is 20. So now, as I look at the data, I'm not going to look just at the median. Now I also want to look at the way that data is shaped and also the interquartile range. And notice that this smaller interquartile range probably means that zip is more consistent. So if you notice Treetop, they kind of go all over the place. They had a 21 day, they had a 100 and looks like 25. So their data is kind of spread out. Whereas Zip seems like that company is, the data is more consistent, and they're a more consistent company. Even though my medians are off, when I look at the other data, I can see that Zip Adventures is probably the more consistent and has the more consistent customers. So the conclusion I'm going to draw is that Zip is more consistent. And we could begin to talk about why we think maybe Treetop isn't as consistent, but for what we're going to do, we're going to kind of look at which data seems to be more consistent. Now, let's take a look at number 2. Notice in number 2 that I have a dot plot here. So when I look at a dot plot, I'm actually going to look at mean because I have all my information here. I don't have any outliers, so mean is probably going to be a good measure to use. So when I start to talk about heights, I'm going to do girls and boys. And when I do the mean, remember that I have to add all of my data points. Now, there are 12 heights for girls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each one of those dots is going to have to be added in. So when I go to add this for my girls, I'm going to add 63. I have 3 at 64. I have 4, and I'm getting these because they line up right there next to the boys. So then I have 4 times 65, and then I have 3 at 66, and then I have that lone 67. So again, I need to add all 12 of those numbers. When I add all 12 of those numbers, I'm going to get 780. I'm going to divide that by 12, and I'm going to find out that the mean height for girls is going to be 65. So girls' mean is 65. And then I'm going to do exactly the same thing with the boys. So I have a 66. I have 2 67s. I'm going to add 2 68s, 3 69s, and then I'm going to add 2 70s, and then I'm going to add 2 71s and a 72. So again, with the boys, there are 13 data points here, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I need to make sure that I've added 13 numbers. When I add all that together, I get 897 divided by 13. The mean height for boys is 69. Now, when I look at the shape of both of these graphs, if you kind of notice when I went through and I started talking about the numbers that I have to multiply, notice that I started with 1, then 3, then 4, then 3, then 1. So the data for girls is nice and evenly distributed. If I went here, I have 3 to the left, 1 to the left, 3 to the left, 1 to the left. Same way with boys. If I go right here to the mean, the middle, I have 2, 2, 1, 2, 2, 1. So my data is nicely shaped, and both of those are symmetric. Now, when I look at the spread of the data, this is where I have to do the MAD. And remember with the MAD, I now have to go through and I need to find the difference between the mean and each data point. So when I do this, I'm going to end up, for MAD, with my girls, I'm going to be adding 2, and then I've got 3 ones, so 1, 2, 3, and then 65 is the median, so that's going to be zeros, and then I've got another 3 ones, or difference of 1, 2, 3, 4, 5, 6, and then 2, so that my MAD, when I total this up, is going to give me 10, and then I'm going to divide that by 12. So then when I divide 10 by 12, my spread is going to be 0.83 with the repeating bar over the 8.3. Okay. Then I'm going to do exactly the same thing with the boys' data. So my boys' MAD, all right, again, it's going to be, and what you have to do is remember that you have to take the mean and then just subtract to get each of the differences between the mean and the data point, and then we're going to add it all up and take that average. So 3, and then I have 2 2s, and then I've got 1, 2 1s, I have 3 there, and now I'm going to just kind of go backwards, and I have 2 more 1s, plus 2, plus 2, plus 3. So that when I add that difference, that's going to give me 18. I'm going to divide that by 13, and then the MAD is 1.38. Okay. And again, as I begin to draw conclusions, both of their data is symmetric. This just goes to show me that boys are actually about 4 inches taller. I know that this data is pretty valid because as I look at that MAD, notice how small the MAD is. So because my MAD is so small, that tells me that this data is consistent and that my mean is actually a good measure. So my conclusions, boys at this point are taller. My data is consistent. So boys are taller. Both sets of data are consistent. So both sets consistent. Okay, now we're going to need to flip the page over to do the second set or to do the back of the notes, but I'm going to run out of time on the video, so I'm going to stop this video and then I'm going to flip the page over, come back, and then we will finish up the back page. So you do need to go on to the second video to get the back page of notes.